This is a question that has to do with the chemical formula of a compound, and I can also say molecular formula because we are dealing with a molecule. In this case, we will be working on an organic compound, that is a compound that contains carbon and hydrogen. In the question above, we've been given the mole ratio of the compound, which simply gives us room to determine the empirical formula of the compound. So from the empirical formula, we'll then proceed further to determine the molecular formula of the liquid. Let's start by stating the empirical formula of the liquid. So we have carbon present and we have hydrogen. So how do we determine the number of atoms of each element present? That will be based on the ratio. We have ratio of carbon to hydrogen to be 1:2. That means we have 1 atoms of carbon present and we have 2 atoms of hydrogen present in the liquid. Now we've gotten the empirical formula, so we want to proceed to determine the molecular formula. But before we do that, we need to know the molar mass of the compound. So it is with the molar mass of the compound, or the molecular mass of the compound, that we can determine the molecular formula of the liquid. So molar mass equals mass divided by moles. In the question, we've gotten the mass to be 0.12 grams. That's stated in the question, but we do not know the moles of the liquid. Another thing to tackle. So let's proceed. Moles will then be equal to volume over amount at s.t.p. The volume of the liquid is 32 cm3. While the amount at s.t.p is 22.4 dm3. They are in different units, so we need to convert dm3 to centimeter cube, and we'll be doing that by multiplying 22.4 by 1000, which should be giving us 22,400. So we have that in centimeter cube. And calculating this, we have 0.0014, our unit, moles. So we've gotten the moles of the liquid. Let's proceed to substitute back and the formula written here, that is molar mass equals mass over moles. Molecular mass of the liquid equals the mass given in the question, which is 0.12 unit in grams, divided by the number of moles we've gotten, which is 0.0014, and this equals 85.7 grams per mole. And because we are working with a whole number, it is a compound, so we'll be approximating this to 86. We have the empirical formula and we have the molecular mass of the liquid. Let's proceed to do the final step of the solution. So the final step now, we want to determine the molecular formula of the liquid, and to do that we'll be applying the formula that says molecular formula mass equals empirical formula mass into brackets of n, where n is a whole number multiple. For the empirical formula mass, which is equal to the sum of the atomic mass of each of the elements present. So carbon is 12 and hydrogen is 1. We have 2 atoms of hydrogen present, that's 2 times 1. Adding this, we have 12 plus 2 equals 14 grams. That's the empirical formula mass. So from here now, we've gotten the molecular formula mass to be 86 grams. Then N, which is the multiple, will then be equal to the molecular formula mass divided by the empirical formula mass. So hence we have N to be equal to 86 grams divided by 14 grams, which is equal to 6.14. And do not forget, we are dealing with whole numbers. Approximately we have 6. So that means the multiple of the empirical formula in the molecule is 6. Molecular formula equals empirical formula into bracket of n. So molecular formula equals the empirical formula, which is CH2, into bracket of 6. That's multiplying each of the elements by the subscript outside. We have C6H12. So let me quickly explain something here. The molecular formula of a compound is the multiple of the empirical formula of the compound. The compound can be in any form. It could be liquid, it could be a solid, and it can be in gaseous form. So with this, we've come to the end of the solution to the question, and we've gotten the molecular formula of the liquid to be C6H12. Do like to subscribe for more if you find this video helpful.